Good afternoon, everyone, and welcome to our webinar series. My name is Connie Chijara, and I'll be facilitating today's webinar. I have the privilege of introducing our speaker, George Krafft. George is currently the CEO of Sized IMS, a division of Sized Corporation, where his team sets new benchmarks for the optimization of mining by stochastic scheduling and analysis, extensive layout design and analysis of new mining technologies, management operating systems in underground mines, amongst many other things. George's experience in the mining industry consists of 10 years in the production environment and 23 years in the consulting environment. Today, he will be speaking about using data to improve productivity in mechanized mines. Please enjoy the webinar and remember to post your questions in the Q&A section.
Hi, good afternoon all. Yeah, my name's George Krafft. Thanks very much for the introduction. I'm dressed for the occasions only because of COVID, but you'll find that this is actually just a t-shirt, but I think it's quite fitting because I think we have to try and bullshit all our clients and bosses that we actually dress up well. Meanwhile, we're probably sitting in shorts. Anyway, my topic today is using data to improve productivity in mechanized mines. Really what I look at is, and I say, well, what is production? And to me, it's grouping resources, planning, backbone measuring system together. By doing that, you create work. And then once you've got work, then you get data from work. And I'm just going through this. I know you probably all know this, but I just want to frame it. Then by doing that, you need systems to hold this all together to create the environment where you can actually at least understand what's going on and you've got productivity coming out of it. But really what you want to try and do is get to optimize systems. Your system needs to try and optimize all these elements and put them all together in a rather rapid and continuous sort of format. So if I look at what are resources, I look at all the controllable resources we may have in our mining, mechanized mine. Could be the layout, your tips, your workplaces, logistics, is the material, what broken ground you get. Then you've got to execute your plan and you've got to allocate the resources properly, where you've got operators, machines, support teams, maintenance, services, mining rules, and you've got to put them in mining rules so they all kind of make sense and actually allocate properly to each other. And then also obviously is very important in mechanized mining is your maintenance. Your maintenance plans need to be put in together. But that's all very well until you start mining, and then you find that through each one of those, you start getting lost time events. And the lost time events and layouts could be, well, and this is quite common, is your tips aren't in place. Your tips are down. The tips are far too further than they should be. Workplaces, you've got geological features which happen often, and your ventilation catches you short, and suddenly you realize you can't mine there because you don't have enough air. Especially these days with diesel LHDs, you need DPH filters, otherwise you're starting to put too many carcinogenics in the air. Blocked logistic systems. You could have on your material side is that you're not getting your materials in broken ground, so you've blocked ore passes, etc. All happen. And these are things that we have to get rid of, but unfortunately they are one of those things that we've got to make sure that if they do happen, how do we react to them? On the execution plan, you could have absent operators. I mean, this happens quite often, especially now in COVID. You get a lot of people that are sick, and that aren't able to come to work. Machines break down. You've got support teams, low complement. So you might have other teams that are meant to support you doing secondary support or whatever, and they low complement, can't work. Maintenance backlog starts catching you. Also getting parts in maintenance. We find that now it's not as easy to get parts. The mining rules, the non-compliance to mining rules, where you mine a face too far ahead, or your your drives aren't far ahead enough against something else, and suddenly you sterilize a face and you can't use that face as well. Maintenance plans, the non-compliance to that, meaning that you get unnecessary breakdowns and you get times when it's been maintained in the correct time or not maintained at all, and therefore has an issue. These all, excuse me, create known lost time and also unknown lost time. Now, known lost time is a better lost time, I guess, if you wish, because at least you're measuring and you know it. Unknown lost time is when you don't know that time, you're not measuring it. It's there, but you can't quantify it and pin it. And that's a big problem. And you want to try and get your systems eventually to start working, to start getting unknown lost time, a better grip on that. So with these two resources elements, you will unfortunately always get, because of the lost time elements, you get events, you get lost time production. We get that. It's not a cheese factory. It's going to happen. But when we do that, we want to lose the least. I think that is the catchphrase that I'm trying to drive here, is that through this whole endeavor is that we must try and lose the least. When we get it, we must react fast enough that we actually don't, and react and create a better plan so we can not lose as much. So if I look at the planning, there's a long and short-term planning. You always want to create a valid plan. And I'll explain what a valid plan is now. Your plan must be in line with your year's plans or your 5-year plan or your long-term plan. That is important, so not to get yourself mining out of orientation to your major plan. To mining rules. Now, mining rules could be that you want to create a face shape of sort. In a board and pillar mine, you want to keep all your boards as square as possible. Some people say they want to go in a Christmas tree shape, or an inverted Christmas tree, or an angle, we call it an arrow type shape. That's up to the rock edge and all the other factors. Mining rules also is that you might say, well, I've only got so much power, and I've only got so many gully boxes where I can actually plug in my equipment, and I'm drilling or putting support in, and I need to make sure that that's coordinated well, so I don't get to a point where I can't mine. Your current status and where you are at the moment, how well you're doing, what is it, and also your cycle times that you're getting so far, and to know all this, because that's quite important to be able to put in your plan. Then you want to get a valid plan from that. Now, a valid plan means that it's, and I see it quite often, is they say, oh, we can get 120 meters per fleet of an LP piece of equipment, and therefore we'll put that in the plan going forward. But no one's considered how many faces there are, no one considered how far it is to the tips. And because of that, you could create a plan that either you're under planning because you could be better, or you actually are hamstringing yourself and you're creating a plan that's not even achievable, which is very important to actually get to. And then once you get your plan, obviously you must communicate that, and that's and there are many methods of doing that. And once you do that, you create knowledge, because now suddenly everyone understands what your long and short-term plan is, and that is a cyclic event that rotates through time. Okay, so then we go into your micro planning, your shift plan. This is where I feel we don't do very well, but we need to react much quicker to a change in environment underground. Yeah, you need to analyze your data. So this is where it's very important, and through my topic is that we need to get that good data and the right data to create knowledge. Then when you got knowledge, then by reacting quickly, you can then create a new informed replan, which gives a whole picture of and it needs to create the whole picture. It can't just be, I've just got a breakdown and therefore, or my tip is down, and it's got to understand, well, if the tip's down, is there another tip? Is that tip up? Is that working? Is it possible to go there? How far is the tip away? These plans that you always have to do must be in line with your plan. So you can't be now planning outside your plan, because you haven't done the due diligence of making sure the rock hinges, ventilation, all that are in place, and then you could actually be mining out of sync, and you could be ruining your future. So what I'm trying to say is you don't want to, you want to look for the long-term benefit with your plan change, and not just a very short-term look at your plan and then you mine yourself into a corner. All your plans must also adhere to your mining rules. And with that, you must validate your plan, impacting next shifts, but validating plan is making sure, have I got the operators that I want? And have they all got the right licenses? Are you got the right fit for a machine? Is the right LHD doing the right work? Is the right roof bolter doing it? Because sometimes they don't fit. That area could be a little bit higher than it should be, and therefore your roof bolter doesn't quite fit. So now you're trying to make a little plan around it, and that's not good, because you're going to create incidents and accidents. Communicating your plan. Now this is now becomes key, especially in short-term planning, because now you're not communicating to your miners, your miners, ship boss, MOs and managers. You need to send that message right down to everybody who is responsible, operators and alike, and including engineering. So it's key to create and communicate that plan. And when you start now working on that plan, you need to measure that plan. As we know, the old namage is, if you're measuring it, you can manage it. If you don't measure it, you're not managing it. And we need to measure and measure and measure. And that becomes a cyclic as something else changes, and whatever, you understand what's going on and you create that plan. So these are the background effects on what I feel is important in planning. Data. Now data, you've got a couple of pillars of data I put in here. You've got safety, where you've got incidents, accidents, where that happened, any remedial action, any standard changes affected their special instructions. You need to know this when you're replanning. You can't just go there and then it's forgotten, and the person who plans wasn't privy to a special instruction or a standard change. From the mining cycle, your cycle times, you need to understand what cycle times you get and what you're getting. Cycle times also, a lot of people just rely on hearsay. I've done a lot more of time studies, and I find it's invaluable to do time studies, and not just on day shift. You need to do the back shifts as well. The big reason behind that is that you actually see a whole lot of other things happening that you didn't realize in your mining cycle. And it's also to understand those mining cycles. Through your data, you want lost time incidents. What are you losing? So you start measuring it. Because as I said, if you start measuring it, you can start understanding it. The more you measure it, the more you get controlled or known lost time and unknown lost time. You can start reducing that. Reason of lost time, what was it? Workplace status, how am I doing? Where am I? I'm 30%, 40% at the end of shift, or where am I now? So that could inform what could happen for the rest of the shift. You don't want to now schedule a charge up at an area where you've only got half an hour going and using emulsion, and well, I could squeeze it in, and by doing it, you don't gas properly. Also, what happens is then you delay the blast, and by delaying the blast, you delay the next shift, which has a major knock-on effect. Effective work, earned hours. We want to know how much you're actually getting out of your system. Earned hours, I'll explain a bit later what that means. Productivity maintenance. So on the maintenance side, your pre-start checks, you want to know breakdowns, root cause analysis, machine health, condition-based maintenance. All of those become quite important going forward from your maintenance point of view as well. So you want to have a good grip and measurement of that in data. And on your people side, your absenteeism, your attendance, training, what training is happening, what leave. Now, we try and push hard to make sure that we start understanding what training is coming up and what leave. And now, a lot of the HRD guys don't like me saying this sometimes, but unfortunately at the moment now, training wags us in production. So we find that suddenly you've got 3-4 operators off to training because they said that's the time, and training are optimizing themselves by filling their classroom, where sometimes I say, well, I'd rather not be as optimal in training and make sure I'm optimal underground, but not to break any rules and laws, and make sure that everyone is trained is important. So I think we can do better at training. Even leave is to plan that better and have it up front, so we don't get caught short with leave. Your cycle times as well. is understanding how each person is reacting, because they could be reacting differently on a machine compared to someone else, which in turn helps identify training potentials. So, and as I think we all know, is this data, unfortunately, is stored in silos and it's used in silos. And not often we get this coming across, but we need to start bridging that gap and creating a common data storage with one source of the truth. Some minds call it, or companies call it the data lake or the database of sorts or whatever. There's a whole lot of names. I think it's very important to try and create that together and get that going. All right, so then you've got your backbone systems. Now, to get your data, you need to have the systems now, and they're getting quite advanced these days. This is just a cross-section of an example of a mine where we need some IT backbone network, and this in red, and that would be your fiber optic cable going down to those workshops over there. And then you need to have Wi-Fi networks. So excuse that, but that's just what happens. Then you have Wi-Fi networks as far into your faces as possible. I know there's some good work being done where they start looking at the last 30 meters and creating networks right up into the face, which is going to be key to us understanding what's going on. You need your other systems that you've got, your IoT connectivity to the machines, equipment, belts, etc. If you've got VDS, PDS systems, and there's all the systems there. There are many others that need to be put in place. And then through this, you need to put a hub of a control room, a monitoring room type system, where obviously all that information is then reallocated and escalated and sent out to many other people areas where you've got the central brain of where information is dispersed out. And then through that there, you want to have systems where you can actually control this data, one in the control room and through tablets or radios or other means back to underground workings into these areas that you've got your Wi-Fi networks. What I would say is systems requirement to be able to do this whole and coordinate this whole system is you want to do task scheduling where you're looking at 2 weeks plus of information going forward, so you can make sure that what you're scheduling is not damaging tomorrow or the next day. Preferably an auto task sequencing so that you put rules in and we know what task comes next. Rules-based interactions, as I said, you don't want some faces ahead of other faces. You want to try and maintain face shape. Rules-based relative to face advance, same what I've just said there. Machine tasks, what are the machine tasks doing? If it's a different machine, how does it behave? Non-machine tasks, talking about other people that might be coming to put vent columns in or something that's more manual tasks. You also want about a flex the task time to elements like face length or tram distance of that, so your times become more realistic so when you're estimating and coordinating everything together, they must mesh together. On your task rescheduling and equipment reschedule, you've either got live systems, so you want to be able to do that live, or if you don't have a network and then you need to, if you're offline, then it still has to be able to update, and the tablet manages what it knows and carries on planning and updating what you're doing. You also want to task reschedule. You can either manual task, meaning that you've got a high-end controller that will manually organize the work, or auto. Now, I like auto if you've got good rules. The challenging manual is you need quite a skilled person to be there to be able to do it. And secondly, is that person can be a bit slower than an automatic system. I'd rather have automatic system with a validation to your ship boss, miner, underground, or even MO, and understanding if they're happy with the plan. Optimizing algorithm. Is this where you want to do is start understanding, because there's so many permutations underground where you could say, well, what next should I do to make sure that you maintain your face shape and coordination and make sure everyone's got the right valid license to the right machine. So you want to optimize that with algorithms. I've seen some where they use a genetic algorithm to run through many permutations to actually come up with your different set of priorities to allocate. You also want to meet your priorities within your mind, so that you might have ends that are prioritized and they must be prioritized going ahead. And from your control room, an operator running the system, if there's no IoT intervention, meaning that it's more of a manual input from the control room or operator, they must be able to start the task, they want to be able to log lost times, they must be able to end the task, log hours and volume of work, so how many machine hours, etc. going forward, where the control room can do a final edit on the system is quite handy. If you've got an IoT systems that can update the tablet with a mature IoT system, you can auto start tasks. You can do some lost time delays. I find some delays aren't that easy, especially the softer type delays of, say, a person needing to go to have a break or something like that. Obviously, we don't know what that is, and there'll have to be some intervention. When tasks are ended, how many whole by whole information coming through, logging hours and volume of work going forward all the time starts becoming quite nice. And when you start looking at interfacing with pre-start checklists into a tablet system, it's quite handy to have information coming directly off the machines through an IoT type system. Other services you'd like the system to try and be across all machines and not just your key machines. Even the support systems like the utility vehicles need to be coordinated in time to make sure they deliver services and materials. Your engineering integration is quite important, I find, is that you want to eventually organize that the engineers know what's going on in production. And similarly, when a machine goes for maintenance, it needs to be integrated into the plan. And services, if geology or survey or ventilation or whatever has to come to your mine site, it's quite important to get that. And why that's very important as well is that with the advance of getting PDS level 9, meaning that a machine will actually stop if someone's in the radius of about 5 meters, you can't just have anyone coming to say put survey pegs in when the machine is running. We'd rather plan that so that it comes through, so we create the least loss of time, because it is a necessary function. We just want to plan it in the right time. Right, so if you look at the system and you're looking at your monthly production, you got on this axis here, you've got production per month and you've got days. Now, I know it's not very straight like that, it's usually quite a zigzag line, but your system potential of a fleet, we call the blue plan, and this is only planned maintenance and no other lost time included. So that's like the best you can get. Now, and then what happens is a lot of mines with no system that I'm talking about, you got limited to no system, you would get a production somewhere lower than that. Now, from my experience, and it can vary because every mine is very, very different, I've seen 20 to 30% gap in this sort of position is quite possible. So by putting in a system where you can start saying, I'm reducing known lost time or looking at the next best plan, you start improving that. Now, how much that does depend on how well you adopt it, what the systems are, but there's always is an improvement, and it could be 5–10%. And then you start, once your system starts getting mature, where you start looking at reduced unlost time and looking at next best time, it starts getting better. Now, what happens in this case, when you start getting to your mature system, you start realizing that I might have a machine design I need to change or something. So we call that material engineering. You would then say, well, let's readjust it or change some logic in the workflow of going forward, because obviously that's what data gives you. You'll find that you'll take your blue plan and your nameplate and you'll make that steeper. And because that's steeper, everything else, and readjust going forward to that. And that's what you want to do, is you've got to continuously not just get better at doing your work, but and not having as much lost time, but you also want to improve the process. So from all this data, that's where you get all that information as well, to be able to do that. If I zoom in just to a shift and looking at how a system could track, here you've got blue plan, and here you've got your system plan that's in place. You find that you're tracking, and normally you'll track parallel to your blue plan, no lost time. And then what happens is you've got a machine breakdown. It wasn't on the critical path, but it did have an impact. So it creates a bit of loss, and then that machine is fixed and it starts tracking against the blue plan. And then you get a critical path machine that breaks down. Because it's breakdown in a longer period, you start losing overall production until you get to a point where it's now replaced, and then you start tracking back. And you'll find normally your how you react to these and how you should plan is it'll zigzag along your average plan that you want to keep for that month. Configuration inputs for the system. In your production area design, you need, obviously, from any of your planning systems, you would want workplace names, workplace sequence, independency rules, distance between or time between workplaces, because you want to be able to start tracking and saying, well, what is the right order? Say a miner should go and make safe or declare safe, etc., to unlock the right amount of work, but not to make it too difficult in that he has to, if he's walking, to make it too tiresome for him. On the labor side, obviously your employees that you've got, your team groupings, how they group, but also what valid licenses are they, and you've got to constantly understand when licenses are expiring for the training. That's where your training roster comes in, and any leave that's put in there, so you start getting attendance and understanding of that. Also on your machines, machine names, which is quite obvious, your groupings, tasks, machine production rates. Each machine can have a slightly production rate. Some LHDs might have a 6-ton bucket, some could have an 8-ton, some have push plates, some are higher or wider than others and contact corners as much. All that becomes quite important to about plan and prioritize the right machine, the right place. Also your plan maintenance schedules. How often do you schedule and plan and do that coming through? Is it conditional based, or is it on a cycle time on calendar? Your preferred operator priorities. So you can say, well, this I'm better at writing this LHD, so therefore I'd rather put that person on there, and rather than have just another person with the license on there, unless they have to fulfill their license obligations, otherwise they lose it. We schedule that in. Mining rules, as talked about, phase shape, proximity allowances of work, is that you don't really want to blast a board and a panel together. Or in some of our mining methods, your face and your ASD, you don't want to blast together, because they're one, you need the throw blast space, and they're one to take up space of that. Electrical layout limitations, you might have, so well, the plugs that you put in there you only have so many kilowatts and megawatts in the area, and therefore you have to allocate properly so you can not get to a point where you overload your transformers. Workplace conditions, if your support regime has to change. End of shift rules and start of shift, what happens, how does that all work, because that becomes quite important. This all gets to you put this through an algorithm, an optimizing algorithm, and then eventually into a database, into managed portals where you can actually start communicating the information. Now, the systems for mechanized mining, these are example of some of the tasks that can happen to affect a blast. You'll have a safety meeting in the morning. You need to declare the face safe. It was blasted, so therefore it's got to be cleaned. Then after that, you've got to prep it for support, mark off, face drill, and charge up, which I think we all know. What's more important here is that each one of these timelines, because this is time going across here, and these are the is working a value driver tree to try and work out the volume of that work, the standard time, what they can work, the setup times, and all that, to actually, because the whole idea is you want to create the best estimate to be able to clean that, because that becomes your standard time, and off your standard time, then you want to be able to variance and understand where I'm getting lost time. So looking at this, there's quite a few products out there. I'm looking at perhaps one of the systems I looked at is the Sims product. it's divided into a Sims portal, which is the control room, which is on a PC and then a tablet. Going forward in this is what this product looks like, and there are quite a few. This what generally would be in the control room, but it can be in any tablet. Here you've, on this axis here, you've got your shift time going forward. Down here, in this case, you've got equipment list, but you could toggle between labor or workplace and get that list as well. This blue grain area here would be shift activities before shift, like you're traveling, safety meeting, etc., etc. The red line denotes the time now that the system is seeing. The area in dotted going forward here is the planned work for that shift against each one of those machines. In this case, the blue is the work that can be happening going forward. So that's the reschedule of work going forward. And the bottom here, you'll get information coming through what's ever been logged on the system. As time progresses, as you see the red lines moved over, it pushes all that work out going forward. This now has changed the workplace to workplace. You can see all the workplaces going forward. As the shift progresses, the timeline has moved on. Work has started. In the green here means it's started in time, and the yellow means I'm overrunning on my standard time. Similarly here, the pink means I started late according to my shift plan that I had going forward. Here in this case, a delay was logged, so you can actually start seeing that that's now pushing it out, and that will naturally push the blue out because no work is happening there. And by virtue of that, it knocks on effect and makes all this valid. The whole system is always valid, that you can't allocate a machine twice or two machines in the end, if that's the rule. Similarly, at the bottom here, all the tasks that are started, whatever delays are logged in at the bottom here that the operator can see, the control room can see. On the app side and the tablets, can be either the Apple iOS system or the normal Android systems. You look at, and what you're really getting here is the headings, when it's last synced, the synchronizing button, have I got signal or not, some of your battery information. This is an Android system, you can see there. You've got my tasks, section tasks, and notifications. Section tasks would be what you saw in the portal, and notifications would be those lines coming through of the whole section. So this is also logged in by an operator, so it filters for that operator his work or their work. In this case, this was an LHD 101, and his task is cleaning, and he had 3 tasks for the day. Hopefully that's not the case, there should be a few more. Same concept, you've got time on the top, the tasks at the side, and then and your red line pushing your blue line with your dotted line as your shift plan. So what you can do, it's a very simple system where you press the start button and the task starts. And then what happens is this bar will go green up top here, the background goes green and grayed. If your system, and you plan to configure it that they can be multitasked, so you can actually have this one running at the same time, then you could also start that one, but there would be a warning. And when it's grayed, then you just click on which one and you can then stop it at the end of the task here. But going forward, so now what happens, this person is working and they get a delay. Now the delay we've designed into either a minor, major, or critical severity. Minor means that the operator can fix it himself. Major means that he needs some help, like an intervention. It could be an artisan or the mine overseer to come see, or a rock angel, something like that. And critical is the one we don't want to use, where we had damage to a machine, injury to person, etc. going forward. So in this example, we put major, and then also it's caused by or influenced by the operator, machine, or workplace. In this case, it's a machine. And therefore, because of that, it's pre-configured list of drop-downs of that combination and says this is mechanical parts. Once that's done, it's saved. And that then puts this activity into delay. You can see this goes red, that goes red here, and the control room would also get a notification that it's red. At this point, this delay has not been acknowledged by the control room. When the control room sees that they're on their screen, they will acknowledge that, meaning that the correct escalation workflow has been taken into account, and this work carries on. At a point when the operator says, no, this has been fixed, presses a continue button, and now this jumps back into the planning mode and then continues as per normal. And at the end, you can end the task. By ending the task, it'll ask you how many holes you drilled, or how many, what's your engine hours that you finished with, what's your percussion hours, etc., and put that in. That's if it's not connected to an IoT device. If it is, that will be automatically inserted for the guy, and he can just check to make sure that he's happy. Similarly, if he's ahead or behind in progress, you can press on the progress button here that you can see, and you can edit that on the fly and say, well, actually, instead of 1 out of 10 loads, I'm actually 3 out of 10 loads, and therefore I'm much further ahead. That gives information back to the system to say, well, because of that, the next task coming after that can be allocated earlier. If that's quite a big variance, especially on a delay, you might say, well, I need to replan and rather perhaps reshuffle machines around, and the system will automatically do that using a genetic algorithm to optimize the work going forward. Within a work day, work shift, examples 5 o'clock in the morning, the end of shift, so there would be a plan coming out at that end of that shift. That plan will then inform the next plan of the status of machines, status of faces, how far you got to work. Obviously, there's a new set of labor coming in, but through your controls of security and clockings and lamp rooms and all that, you can start understanding who's attending, who's at work. And by doing that, getting that data from that, you start understanding how best to plan your day. At a point in time, in this case, it was 5 o'clock was the end of the previous shift. 5:30, unless you got blasting, you might be a bit later. We call it the P0 plan. That dotted plan gets finalized by the ship boss, where he's got the tablet. In his tablet, he can change and work out what he wants to do. The algorithm suggests to the ship boss what is the best plan. He can then rechange priorities to organize to reprioritize ends if he requires. But at this point, obviously, he's only got information from underground, which should be the same as what's been logged on the system. Then as they go underground, they start working, something happens and the miner's not feeling well in this case. And then because of that, the delay gets logged according to how I explained it. And then a replan is now we need to get someone else to fill in the miner if there is someone. You can't. If it's an operator, is there another operator that you can reallocate? Now the challenge comes if your key control is on surface, you'll have to go get the key again, another key, or we're starting looking at how do we create virtual keys where through the system we can authorize the allocation of that key. You could have a burst pipe going forward. You could have a machine smoking and therefore it stopped. There's a breakdown of some sort, and etc., etc. Through this there, you can create many new plans going forward in the shift. That's not a problem. Each time the plan is resynced back to every tablet, and every tablet is set at the moment every 3 minutes. It's the information is sent back to the control room through the SQL database, and then you get an end of shift plan. So that's generally the cycle of what happens in a shift. To connect IoT information, we've used this in this example. The IoT NXT company was used, but many companies do this. They've got a Raptor. We've got 2 types of machines. These are the ultra low profile machines, quite intelligent, got computer running them. So it's easy to get information. It sniffs the canvas and you actually get good data that goes into SQL. But on these other machines, these were the old generation XLPs. They were not that intelligent. And because of that, a lot of more information has been formed. Ideally, what we would like is to get timestamp holes drilled, how long it took to load a trip. We would like to know the engine hours, etc. But if we start knowing more information, it just only helps later on to start optimizing those machines to find out where the delays are, so we can do either material engineering training going forward. These algorithms that they set up go into a database which we replicate off and goes into the system, which will then update through the sim system. Here's an example of what we did, where you could see each blue dot coming through here was a hole. So every hole coming through. What's interesting, there was a gap here between those holes there, and the delay wasn't logged there, but if you add up a lot of those dots, will be this overrun time that we actually got here. There was some time logged there, delays logged there, which you can hover or find a report of what was happening. On the reporting side, and I think this is valid for any systems really, is there's your normal standard reporting, and with good data, you find that that's normal stuff like availability, utilization, production run charts, what delays you're getting, mean time to failure, mean time to repair. There's a myriad of them. Your tonnage comes out of that as well. Your meter squared, your efficiencies, and all that come through. Then you got user interface reporting, where you start looking at Power BI type systems where it's more reactive. And these systems sit on top of a database that's pre-configured, and you can say, well, I want information from this date to that date. I'd like to look at this machine only, or group of machines, or this type of operator, or this operator and how they're formed. And then you go into in-depth analysis, which is a lot more fault finding and understanding, and looking at your consequential losses that you've got, and what other knock-on effects and losses you've got, and appropriating and portioning costs back to lost times, and doing that. And that creates someone who's probably a better analyst skill to do that. But looking at your attribute analysis is quite handy to do that sensitivities going forward, so which helps start informing the management team what they should do going forward. Some of the end of shifts reports we find quite handy are these, where we start, once you've got quite a bit of data, you start creating your normal curves of how work is done. In this case, this is on a day. These are your cycle times that you are getting per hole, and here is the frequency that happens. So in this case, this is for bolters. The P80, that's the standard that we would plan at, and you'd find in this case, this bolter, each cycle time per hole was longer than it should have been. That was 2 minutes 10, and that's 2 minutes 20, and bolter 209 was actually way off the curve. Now you could then cross match that to say, is it constant to an operator or something? That could be of the day, but you could do week, month, year, depending on your data, and start correlating together. Drilling, same sort of thing. We had a bad day going forward. Yeah, but on previous panels, and that you start finding that also what the cycle time of that panel was compared to other work. So that becomes quite handy. Also within your delays, you can look at where I am and what delays am I getting. Am I getting more or not delays at the moment compared to what I'm used to in hours or number? You can also start looking at the normal stock standard availability utilization. There's many ways of showing this. It's really up to you. Mean time to read, mean to failure. Could be by machine, by time. You can slice and dice it the way you wish. Run charts, I think you're all familiar with that. I know Anglo-Americans are going for an operating model where run charts are becoming quite important to start understanding your money. On other reports, what we find is, when we look at an analysis of lost time, there's a couple of ways. We can look at that duration of events, so how much time each one of those types of failures did. We can group them, we can do many ways, but you can see it. Also, you can say how often is that happening of that. So you can look here, example, that on your pump, on your drill rig, you are getting 5, which cumulated up to 4 hours, 10 minutes. Whereas yeah, you had on your LHD 209, you know, that 4, which is really short, but there were a lot of times, but it didn't have a big delay effect going forward. But becomes more important, and this is what I said, I'll come to that earned hours or earned meter squared, is that what we realize that if you look at that mining cycle, the cycle of standard time to effective blast could be, say, 10 hours. Now, if it's 10 hours and we say, well, we're blasting, getting meter squared out of that, we might say for every blast, we might be getting, say, 2 times 8 or something like that, 2 8s or 16. So of 16, we get 10 hours of work. So we can then divide the 16 by that. And so for every hour, we get 1.6, am I getting it right now? Probably, yeah, 1.6 meters squared for every hour. Then by working backwards, we can say, well, then we lost hours. We can start attributing back to say, well, how many hours we lost. Similarly, also earned hours, what it means is that if I planned 3 hours to do a task and it took 4 hours to do it, you only earn 3 hours of that time. And similarly, if the task was meant to be 3 hours and you did 2.5 hours, you earn your section 3 hours as well. So that those two concepts come together, where you actually then start understanding effectively how much production you lost. Because if you talk about to an operator, you lost so many hours, it doesn't really make as much sense, or a mining guy, than you say, I lost so many tons or meter squared or meters or whatever starts becoming important. And then here you start looking at your delays that you can't put into, but there are myriads of ways of doing that. So in conclusion, my feeling is you need to use data to improve productivity by constantly optimizing and synchronizing the following: is the mining layout, resources, which are workplaces, machines and operators, your maintenance, all your services, i.e. your geology and etc. coming through, training, whatever. You must create a valid plan where the plan is now correct to make sure that you're not double accounting 2 machines at the same time and making sure nothing's standing where you could have put it together. You must have effective communication where that everyone is communicated with the same plan all the time so that everyone understands what's going on. So putting it together, you want to constantly create an optimal plan, i.e. the next best plan all the time. So you're always in the next best plan because your plan will change and you must rapidly communicate that new plan. So to coin it there is you want to lose the least. And that's really what we're trying to get to. Okay, thank you. Any questions?
Thank you very much, George. That was a very insightful webinar session. There are 2 questions currently. The first one is from Richard, and he's asking, can the system communicate via SMS?
No, not by, because usually underground SMS unfortunately doesn't work, and a lot of the mines put you under many firewalls because the blasting systems are there and all that sort of stuff, and you live on that network. So the system, what it does is it's almost like a WhatsApp chat. It's integrated in there, which is being built now and is being tested to actually integrate a chat function, so you can do 1-to-1, 1-to-many, or many-to-one. So depending how you want to do that. The system is being extended then to video and to voice as well. So that's becoming quite important. Bearing in mind that an operator is working, he mustn't be sitting on his tablet looking at what's going on. So it's going to be more him talking to the control room and or a miner or another operator.
Okay, thank you. The second question is from Stephen, who's asking, how has the conceptual mine design been made a reality, and where is it currently in use?
The conceptual, so I'm misunderstanding it. Do they want to explain a bit more? I don't understand the question, sorry. Because I presume if it's concept, you create a conceptual layout or design. Obviously, if you've planned that, you must take that plan and or that design, and then you've got to test it first. You can do many simulations working through that to understand how that will come together if it's still a theoretical layout. By doing that, you must do stochastic scheduling with a per type arrangement to start understanding your true effect of your cycles that you're going to get, and your production you're going to get with the interaction of all the systems together. I don't know if that answers it.
Okay, thank you. The next question is in the group chats from Tatolo Laseri, who's asking, can the system automatically export reports to email?
Because it's in SQL, you can create systems that would do that, but you've got to make sure where your SQL is sitting. If it's sitting behind the firewall, in the case where we are at one of the mines, that doesn't allow us to do that. So we have to create a port to be able to export it out. Once we can do that and we got the IIT information out, that is very possible and easy to do. There's a lot of automated systems that do that. It can automate that. It can generate on event. It can send you just the correct escalation procedures. Those are rules that you've got to put in.
Okay, thank you. Then there's a next question from Cynthia, who's asking, is the system compatible with other systems used in the control room, such as a modular dispatch system, or is it an improvement of the system?
I would say it's a dispatch system in its own. So obviously anything is, these days we have, everything is written in open sort of service or software where you have to integrate with other systems. So depending which one's better from the client that they'd wish, then obviously you can say, I'll use that. As I say, there are some good systems underground already. Some companies have got them. I just feel that there's not really an automated system. And I guess if you've got your modular dispatch type systems, the surface ones I think are really good. Unfortunately, I think sometimes not all the features are used like most other systems. But if that is a major requirement of the client, so it will have to be looked at to see how that can be done.
Okay, thank you very much, George. That was the last question, and thank you everyone for attending today's webinar.
Just a last comment. I don't know if you can notice my attire, because it's very important to be dressed well during COVID. But this is a T-shirt, so you just you must get a couple because it's very handy. I really appreciate everyone's attention, and have a great evening, and keep safe, and make sure you keep away from the dreaded COVID. Thank you.
Thank you very much, George.
Thank you, George. Thank you, Connie. Bye-bye, everyone.
Bye, Camilla.